All right, so next up is the converter SIG. So Kevin will be walking us through that. He's one of the co-leads of that.
Okay, hello everyone. My name is Kevin. I work as a software engineer at NVIDIA. And although my co-chair Diego cannot join in person today, he'll be attending online to answer any questions that you may have. So for today's agenda, I'm excited to go through all of the converter updates that have been added in the past year. So we'll first go through the front-end converters, then the back-end converters, and then we'll talk about some of the items on our roadmap and ways to get involved with the converter SIG. So the first update we have here is the PyTorch to ONNX converter. So the latest release for PyTorch to ONNX is PyTorch 2.0.1, and it supports ONNX models up to offset 18. There is a very new and exciting preview feature for PyTorch, where there's a new Torch Dynamo-based ONNX exporter that will ship officially as part of PyTorch 2.1. And with Torch Dynamo-based ONNX exporter, there's a new API called Torch ONNX Dynamo Export that you could actually use right now with the nightly builds. And this has some benefits over the existing torch.onnx.export, including the fact that it's all Python. There's no C++ code, and it's built around using ONNXScript for its export. And it aims to implement all of the core A10 and primitive IR ops in PyTorch. In addition, fake tensor support was introduced into Torch Dynamo, and this is a very critical feature because it allows exports for LLMs. It allows faster exporting, allows better tracing of dynamic shapes, and it allows better memory usage so that we're able to see better export for on systems that may have lower device or lower host memory. As an example, to showcase the new PyTorch Dynamo workflow, we could take a GB2 model from the Hugging Face Transformers repo, and you can see that as long as we initialize the tokenizer and the model from the GPT from the Transformers module, all we have to do is call torch.onnx.dynamo export with the model and various keyword arguments or model arguments, and we're able to export this GB2 model with one line of code. As for ONNXScript is also an exciting new feature that, again, is the backbone of the PyTorch Dynamo-based ONNX exporter. There was an existing presentation on ONNXScript, so I'll just quickly go over through some of the highlights. So again, ONNXScript is a useful tool for directly authoring ONNX models in Python, with the bonus on using clean Pythonic code, and it supports ONNX native local functions to better have a cleaner export into ONNX. So for the example here, as was shown in the previous presentation as well. So for GALU, but previously, if you wanted to create this GALU model in ONNX, you would have to use the existing ONNX APIs. And as you can see on the right side, it was a very large, very unwieldy piece of code just to create a simple model. Whereas on the left, using ONNXScript, we're allowed to use Python idioms such as math.square root, use Python operators such as multiply, add, just to create the same, to easily create the same model as we see on the right. For TensorFlow ONNX, the latest release for here is TF2 ONNX 1.14, and it supports offset 18, and it supports TensorFlow versions up to 2.11. So some of the highlights here is that the default offset export version has been updated to 15. We've added a outputs as NCHW export option to automatically insert transposes and network outputs. So previously users had to do them themselves. We've added support for tf.math.comprod and batch matmul v3 into export to ONNX. And there has been various fixes for loop exports into ONNX. Some of these include, sometimes we're exporting infinite loops. Sometimes we were using very large default values for the trip limit, and all of these have been fixed. So if you want more information, you could check out the ONNX to TensorFlow release page on GitHub. Next, for sklearn to ONNX, the latest release is sklearn ONNX 1.14. This also supports offset 15, and they've added support for sklearn up to 1.12. There's a various updates as well, so they've added support for 1 versus 1, quadratic discriminant analysis, gamma regressor, constant predictor, and there has been various bug fixes to improve the export process. And again, you may see the release page for more information. Onto the backend converters for ONNX TensorRT. The latest release here is ONNX TensorRT 8.6, which support up to offset 17. We've added ops support for group normalization, layer normalization in this inf, and there has been a lot of improvements on dynamic shape support for certain ops, including reverse sequence, trilu, and top K. They have updated casting semantics within ONNX and TensorRT, so casting should be a lot easier. And we have added TensorRT layer annotation with ONNX metadata so that users that generate TensorRT engines through ONNX, they could easily track exactly where from the source ONNX models and even further source, for example, the source PyTorch model that their TensorRT engine layers are coming from. And of course, at the bottom, you can see the link to the latest release notes for ONNX TensorRT. For ONNX runtime, the latest release is 1.15.1. It added support for ONNX 1.14, which is up to offset 9. It introduces training on edge devices for desktop and Android, which was, again, another talk that was done previously. It expanded platform support, so expanded CUDA version support and Python version support. And some performance highlights here is that over stock PyTorch, some models such as VIT, BEIT, and soon V2 is up 44%. And some popular Hugging Face models, there are there is a base speed up over stock PyTorch with ONNX runtime. And for different hardware, in addition to the existing backends that ONNX runtime already supports, there are new 2 execution providers added, which is JSCP and QNNEP. Finally, for the roadmap, so this has been something on our radar for a while. So as the ONNX spec improves and converters improve as well, we want a minimum offset support for our converters because it doesn't make sense to support every single possible definition as the operator set improves. And finally, we want to improve community-driven tooling. There was a lot of good presentations today about different tools that do a lot of common things that these converters face, such as shape type inference, quantization tools, constant folding, graph editing, etc. And we want to have a way to make sure that we're pushing these into ONNX in a community-driven and robust way. So finally, get involved. So any feedback, or if you have your own converter that you're working on and you want to get some more visibility on that, the primary way is to join us in the Slack channel. There's a converter SIG mailing list as well if you want to subscribe for any updates or community meetings. And if you have any issues with a specific converter, feel free to always open issues and partake in discussions on GitHub, as the activity is very active there. So that is the end. If there are any questions, I'll be happy to take them. Yep.
It seems like there's a lot of really interesting routes to get Torch exported. You could use Torch Dynamo, things with ONNX scripts. But one of the nice things with the Torch export path was that there was just one export path, so it was pretty straightforward what we had to do. Is there a long-term vision of what the exact path that most people should take in the future is, and are we converging on one? Yeah, so I think perhaps Diego could take this question. My understanding is that Torch Dynamo would be sort of the future of PyTorch export, I guess once it's officially out of its preview phase. And I think, yeah, so we would recommend that path going forward.
I can speak more to that too.
Yeah, sure.
Yes, Dynamo is the future. And things are converging, but the new path forward. The long-term vision is actually export support will be part of PyTorch. And so we will participate in whatever that API is, but there will eventually be a torch.export that you use, you specify ONNX as the backend. And so that will be a unified API that represents all of PyTorch. And so ultimately you won't want to use torch.onx.export or torch.onx.dynamo export. You'll just use torch.export and it will use the ONNX backend. So what we are previewing the Dynamo Export API is what will be the kind of the under the hood of the higher level API, which will just become torch.export.
Perfect.
So we're in 2.1, which I believe should be early October, will kind of be our first sort of official release of the Dynamo-based Torch export. So look for that, but it's coming and it's good stuff.
Awesome. Thank you, Kevin, and the converter SIG for that update.